The first step into finding the pH of a solution is to first calibrate the pH meter. To calibrate the pH meter, the first thing you have to do is clean the probe off with deionized water. Once cleaning the probe off with deionized water, you're going to place the probe into one of the pH buffers that you have. For our experiment, we had pH buffer 7 and pH buffer 4. We placed the probe in pH buffer 7 first, and after placing the probe in pH buffer 7, we waited for the voltage to stabilize, and then we entered in 7 into our pH meter. We kept the data, and after keeping the data, we took the probe out of pH buffer 7 and washed it off with deionized water as well. After washing it off with deionized water, we did the exact same method for pH buffer 4. After doing the same steps with pH buffer 4, we took the probe out, cleaned it with deionized water, and then tested each solution to make sure our pH meter accurately read each pH solution. If it does not accurately read the pH buffer solution, that means that you didn't do the calibration right and you're going to have to do it over again. If it did, that means you're good to go and that you're going to be able to test the solutions accurately. The next step in our experiment was obtaining the pH of the known solutions. In this lab section, we tested about 6 known solutions, being NaOH, acetic acid, tap water, orange juice, HCl, and apple juice. We didn't know the pH of the solution, so that's why we used the pH meter to get the pH of these solutions. For these solutions, they were either strongly acidic or close to being a weak acid or being basic. A little bit of background knowledge about weak versus strong acids is that strong acids completely ionize or dissociate in aqueous solutions. Weak acids will only partially ionize, and by partially ionize, I mean that they don't completely dissolve in an aqueous solution. Strong acids don't reach equilibrium because once it completely dissociates or completely ionized, that means it can't be reversed back. However, weak acids, being that they don't truly dissociate, but they only partially dissociate, that means that they can reverse their reaction and go back to their reactants, and vice versa, so they can go back into the products because they don't completely dissociate or ionize. In our last experiment, we compared the pH behavior of water to a buffer solution, and within this, a buffer system is a system that resists changes in pH when small amounts of acid or base is added to it. It reacts with the acid or base and neutralizes it to keep the pH constant. So within our experiment, the pH kind of was constant. It didn't really change or fluctuate at all because of the buffer.